Great, so today we're looking at the inverse normal distribution. So what's the inverse? Well, it's whenever we do the opposite of something. So what have we been working out? We've been working out a probability when we're given the mean or the average of a normal distribution, the standard deviation, and what a particular value is. We've been able to find the probability. So now, if you know the probability of something happening, and you know the mean, and you know the standard deviation, you must be able to work out the parameters of what that is. So that's what we're going to be doing. And to help us along, as well as my cup of tea, got a trusty old fig roll, great, much undervalued biscuit. Not only is it surprisingly substantial, it keeps you regular. So here we go. Right, here's your first problem. Write it down, get your calculator out, pause the video, start going down the road that you would do just with your normal distribution, and see whether or not you can work out how to do the inverse. If not, don't pause the video and carry on. So what we're doing is we are thinking that we've got a distribution that's looking something like this. We know the mean is 20, so there in the middle is going to be 20. The standard deviation is 3 squared. We know that the probability of it being smaller than A is 75%, so A must be bigger because it's going to be smaller than it. So we are looking for the value that gives us that, if that is 75%. So popping into the calculator, go menu statistics, it's distribution, isn't it? Normal. That's what we were using last time, but we're going for inverse today. And if you get in there, the first thing you might notice, variable, okay, down below at the tail to the left, it is left, it's to the left already. We've got the area. Well, the area is the probability, so that would be 0.75. That's the only new thing from last time. Then we've got the standard deviation being 3. We've got the mean being 20. And the inverse x is going to be 22.02. So A equals 22.02. Now, second problem we might have would be, what will you do if instead of being smaller than, it's bigger than A? And we're saying that's 0.4. Pause the video, give this a go. Right, so I start off by doing another little sketch, or I could go on to here, couldn't I? It's only 0.4 this time, so we have got less than a half, so perhaps our new A is just here, but this time we don't want that. We want, yay, that's rubbish, isn't it? Let's start again. We've got 0.4 is the chance of A, but we want the probability that it's bigger than it. So if the A is there, why have I shaded that in? Because what we want is this, isn't it? What's the area of that? And in order to do that, we just need to go back here. This time we've got a right-handed tail, haven't we? And we've got area 0.4. We've got 3 and 20, and that's giving us 20.76. Right, here's our new problem. pause the video, give that one a little think. And this time we've got a x is bigger than 16. Now we know that 20 is the middle of our curve, so 16 is somewhere below, and we want a to be such as that this probability here is 0.3. We can't do it straight away. We're going to have to think about what it isn't as much as what it is. So what can we work out? We can work out, though, this little region here, can't we? Because we know that that is 16. So we can do that first of all. So I'm going to begin by working out the probability that x is smaller than 16. And I'm going to do that going back to distribution, normal, and NCD as we have done before. So we want our lower to be 0 and our upper to be 16, and then the other things stay the same, don't they? And that's giving us a probability of 0.0912. I'm going to put all of those down there. So if I was to add these two together, then the probability that x is smaller than a is going to equal 0.3, add that and that together, 9121129, and then we can use that going back to normal and inverse, and we want not a right but a left tail here. Where's left? There's left. The area this time, is 0.3912. I'm just going to put everything that I've got there in, and that gives me an A being 19.17 to 2 decimal places. Okay, one more example with a bit more of a context in it, and you'll be ready to do some on your own. Okay, there's your first problem. Write it down, give it a go, pause the video, and then see if you agree with this. So what we're being told is the probability that x is smaller than x equals 60%, which is 0.6. Grab the calculator, and actually before we grab the calculator, just consider it so we know which tail we're going on. We've got the mean there being 20. 0.6 is more than a half, isn't it? So we are looking at this. So that looks like a left tail to me, so that's left. And then the area is 0.6. The standard deviation is 1.5. The mean is 20. And that's giving us an x of 20.38 centimeters to 2 decimal places. In an exam, 3 significant figures unless they tell you. On to so that's your first part. Second part's coming up. As soon as you see it, pause it and have a go. Find the interquartile range of the plate diameters. Right, so interquartile range is between 3/4 and the 1/4 point, isn't it? So the first thing we need to do is say, right, we know that the probability is going to be, you can go less than or more than, can't you? But it's normal to think about going less than. The upper quartile will be at 0.75. What nonsense am I talking? We're looking for our value for our upper quartile being at 0.75. So there you want to be popping back into there. 0.75, if we go that way, if we use this one again, if we said that was 75%, that would still work, so it's definitely a left. All we're doing is changing our area to 0.75. Everything else is staying the same. That is giving us x being 21.011736. Then we need to know the lower quartile. So let's go for, let's call that y, 0.25. All we have to do is skip back 0.25, bang it in there. That's giving us y equaling 18.988264. And then if we take one from the other, you should get to 2 decimal places, 2.02 centimeters. And then we are ready to count and just do some practice. So your practice for that will come on page 46, exercise 3C, and we're looking at questions 7, 8 and 9. Okay, hope you enjoyed that half as much as I did. Cheerio!